Okay, let's look at number 20 from the free response. So again, this is a differential equation one or a slope field question. So because we have seen this now multiple times, please make sure that you have given this your best shot before watching this video. Okay, disclaimer / warning is over. Let's go and see what we can do. So the first thing we're asked to do is we are supposed to graph this on the 8 points given, okay? So again, reminder the way this works, right, is you just plug in points. So for example, again, I'm not going to go over every single one of these, but I might plug in the point 1, 1, and that would give me 1 plus 1 over 1. So that would be a slope of 2. Okay, and then we put a little line that has a slope of 2. Okay, so let's see what we got here. When y equals -1, right, the slope is 0. When, let's see, x can't be equal to 0 because there's clearly a vertical asymptote there. So let's see what we got. When x is 1 and y is 0, it's 1. When x is 1 and y is, what is it, like 2? Sorry, let's try that again. When x is 2, one more time. Sorry, I'm looking at this point. I'm having trouble thinking here. So when x is 2, y is still 0, so that's 1/2, so it's a little slightly less. Okay, let's go the other direction. When x is -1, we get 1 over -1. That's a -1. So this is going to be -1/2. And then the last one, what do we got? We got the point -1, 1. So that's going to be, looks like, what is that? -2-ish. So something like that. Okay. I don't know how they would grade this one. I don't know how they grade this. Maybe they look for where it's positive, where they look for it's negative. I don't know. Okay. Let's keep on going. Let's look at letter B. Find the particular solution and then state its domain. And we are given that it passes through this point. Okay, so this is an interesting one. And I'll kind of talk about a little bit why it's interesting at the end. So let's do our separation of variables. So dy over 1 plus, I can't write here. 1 plus y equals, looks like dx over x. So this is kind of interesting that we're going to take a natural log, right? But I mean, both of them, when we integrate these two, they're both natural logs. So we get the natural log of 1 plus y equals the natural log of the absolute value of x plus some c. Okay, I'm gonna kind of come back to that spot right here in a little bit. So I'm gonna kind of highlight that. It's kind of important. But let's keep on going here. So again, they want us to write this as y equals f of x, and I'd like to be able to solve for this now. So I'm going to go and do our normal thing so we can get rid of the natural log. So we get the absolute value of 1 plus y equals the natural log of, sorry. Yeah, no, that's right. No, it's not. It's not. So it equals this, right? Reminder, these were, these exponents are put together through addition, so we can rewrite like that. And then if I let e to the c1 equal, c, then I could say 1 plus y equals, so this one, notice this is going to cancel out. We're just going to get the absolute value of x times c, so that's becomes c times the absolute value of x. Okay, so we get, actually, at this point, let's plug in our point. Let's go solve for c. So I'm going to plug in the point -1, 1. So I get 1 plus 1 equals c times the absolute value of -1. So I think you'd agree c equals 2. So what I'm left with, let's go back here. I'm having a little trouble following this. 1 plus y equals 2 absolute value of x. Now, there's a couple things here. So first off, we could stop this here. Let's see if it actually works. If I plug in -1, right, I get 2 times -1. I'm sorry, 2 times -1, the absolute value of -1. So this is 2 minus 1, that's 1. So it does work. I could also, if I wanted to, I could get rid of the absolute value of x, right? So I could get rid of that. And the only reason is they're asking this domain thing, and I want to kind of think about it a little bit. So let's kind of go back here real quickly. Let's get rid of that absolute value of x. So we get either plus or minus 1 plus y equals 2 times x. So this gives us negative 1 plus y equals 2x, or 1 plus y equals 2x. So y equals 2x plus 1. Nope. It's like that. Excuse me. That's a big deal. So I get, let's make it negative 1 minus y equals 2x. Negative y equals 2x plus 1. Y equals negative 2x minus 1. The other one is y equals 2x minus 1. Now notice, while we have two equations, only one of these is going to work, right? If I plug in negative 1 into this, I get 2 times negative 1, which is negative 2. That's minus 3. So this one doesn't work. I meant to make that in red, but you guys get the idea. I've crossed it off. If I plug in negative 1 here, I get positive 2 minus 1. So this one works. So first off, I want to emphasize this or this is fine, right? These are absolutely fine equations. The only reason I did the other one is there's a second question, and it's really hard. It's the question about the domain, right? It's saying, and state the domain. So here's the thing about this, because I really had to think this through a bit. So when I look at, let's just kind of look at it from, I want to kind of ignore, I'm going to kind of black these out. I want to kind of ignore this and this right here. So I'm just kind of looking at that natural log line. We know, right, that if, let's say we're trying to remove the x's, okay? So let's say we were trying to kind of make this work. So the natural log of 1 plus y equals the natural log of absolute value of x plus c. So I want this left-hand side to be positive, right? We know that because I shouldn't even say I want it to be positive. That's not necessarily true. We do know that whatever I'm taking this value of has got to be positive. The key here is let's talk about this. Let's think about if I wanted to get rid of this absolute value of x, right? If I wanted to do that, I think you guys would agree, in order to get rid of that absolute value of x, because I'm plugging in negative 1, it would have to be the natural log of negative x plus c, right? That's the only way I could plug that point in. Now, you could argue, so we could say, just to kind of finish this up, we could say the domain of x is less than 0. The 0 is pretty clear. I think you guys would agree. We knew off the bat we weren't allowed to plug in 0, right? You can't take the natural log of 0, so that was pretty clear right off the bat that 0 is going to be an issue. The question is, how do we know that it's greater than or less than? So here's my problem with this, because I don't quite see, I don't see why x not being equal to 0 doesn't work. And the reason I say that is, I think if we were to kind of solve this one right here, right, and we were to find a c value right from here, right, I think if you do that, and you'll have to excuse me if I may be wrong, but let's just assume for right now that I'm right. I think what it does, because I tried this earlier, I think you get this, which is going to kind of make sense, the natural log of 2, okay? So I guess my problem with this is, I don't know why you need to remove the absolute values. Yes, you get, whenever you have an absolute value, you're getting some sort of piecewise function. But I can plug in negative numbers and positive numbers into this, and it produces fine numbers. So I'm not sure what it is about this that they want to force you to choose kind of a branch, right? Normally, I understand why they would want you to choose a branch. Because when we have this natural log, right, the natural log, right, we're going to have either kind of a couple situations, right? It's either going to do something like this, or we're going to kind of force it to do something like that, right? So, but we always have to make sure that our domain value is good. In this case, like I said, they're kind of saying, here would be my guess, and I almost feel like this is a bad question. Maybe I'm wrong. Maybe it's a really good question, and I'm just not seeing, their thought process here. I think here's what they are expecting. Okay? I think here's what they are expecting. I think they're expecting you to get to kind of like here or maybe here, depending on which way you kind of did it. So you have one of these two answers. And then they're saying, hey, you know it's a natural log. You know you're not allowed to plug in 0. There's going to be 2 branches. Which branches is it going to be? Well, it's got to be the one that's less than 0 because x is -1. Therefore, x is less than 0. Like I said, from a gut reaction, that's fine. But I don't like it in terms of, if you think about it, I don't see why we have to restrict the domain like that. That's just me. If I had been on the AP, would I have gotten this one right or wrong? I don't know. I know I probably would have said x is not equal to 0. And I probably would have just stopped there. I don't know if I would have said x is less than 1. Okay, anyway, that is that problem.